Hello, welcome back. This is Calculus by Dr. Oz. Today we have two exercises as an application of the power series. So we have the first function is a rational function 1 over 1 minus 4x. And we're going to try to find the power series representation of this function centered at 0. And for the second one, we have the linear part divided by the quadratic part as a rational function. And we're going to try to find the power series expansion for this rational function at c equals 0 as well. And what we're going to do here is that we're going to make use of the geometric series test result, and in fact the property of the geometric series. So let me just quickly give you a run through of what we're going to do, and we're going to start the video right after. So here we have the convergence of a geometric series. This is something that we did in the beginning of this chapter. Once you have a geometric series, a times r to the n, with r being the ratio of the geometric series. This series is convergent only if r, the absolute value of r, is less than 1. And in fact, if this is the case, then you can represent the geometric series, you can represent the sum of the geometric series by a and r. In fact, it is a over 1 minus r. So the question is like, how can we use this idea to represent the geometric, to represent the power series of the given functions? So here you have a over 1 minus r, and as you see that, keeping in mind that r could be a function of x, so that means the left-hand side of the infinite series becomes a power series. So, for example, if a equals 1 and r equals x, so you have a 1 over 1 minus x represented by the infinite sum a times, which is 1 times x to the power of n. So x to the power of n, geometric series, is in fact sums up to 1 over 1 minus x. So how do we use this idea to get the power series of the exercise that we have in this video? All right, I'll give you more details of that in the video. Let's get started.
All right, let's start. So we're going to find a power series for the function centered at c, and in both cases, in fact, c is 0. So what we're going to use here is the result that we had for the geometric series. So we have the geometric series a times r to the n, with a being positive and r being the ratio. And this series diverges as long as the absolute value of r is less than 1. And this geometric series is represented by a over 1 minus r. Let me just copy that down here. Okay, this is represented by, especially for part A. Well, this is already 0, by the way. Okay, I'll just correct that. Okay, so n starting from 0 to infinity, a times r to the n is equal to a over 1 minus r, and r is supposed to be less than 1. Okay. All right, I also corrected the typo here for c. So what we're going to do next is to sort of like utilize this result. So here, if I take a to be 1 and r to be 4x, then a over 1 minus r is in fact what I have here, right, for h. Okay, but I know that this is represented by the geometric series a equals 1, r equals 4x to the power of n. Okay, so this way, as you see, the function h is represented by a power series. Okay, so I want to know when this series converges. Okay, so we know that 4x r, in other words, has to be less than 1, which essentially means that 4x is in between -1 and 1, and then x is in between 1/4 and -1/4. Okay? So if I want to represent h in terms of power series, we have the interval of convergence to be -1/4 and 1/4, and that comes with radius, the power series comes with radius 1 over 4. Okay? So here the interval of convergence is -1 over 4 and 1 over 4. Okay? And for part B, please watch the next video.